Hi everyone, Engineer Liu here. Welcome to another tutorial. This is part 3 of our tutorials on C programming language. And on this tutorial, we'd like to talk more about variables and types in C language. So let's get started. Okay, so our last example was example 3. And let's create another example, example 4. Okay, so standard process at this point. So example 4, let's see. Let's include stdio, standard input output, our main function. Some of you may be a little bit discomfort that I'm not passing any arguments here on the main function. Some compilers may complain about this, about not passing any arguments to the main function. So in order to avoid that, you can just pass a void argument here, which refers to a void pointer, but we'll get more in detail in future videos about pointers, as I said previously. So curly brackets here define our scope of our main function and return 0. Okay, so what I want to show you here it's the size of the variables in C, which are architecture and machine dependent. Okay, so let's try with some basic types and we will get to more advanced types. Like, so in the past video I show you int, short int, a long int, and a long int. Okay, so we have, so let's take a look at first for integer variables, int, a short int, long int, and long int. And in C we have this function which is sizeof, which prints the size in bytes of a certain variable. So let's use printf here, size of int. That's sizeof is a function which returns long int, so here we have to pass ld, and then size of a, which is our integer, printf size of short int, here ld \n for new line, size of b, printf long int, size of C, and size of long int, which is okay. So we're writing quit. Here I want to show you a flag that you can use in GCC compiler for it to print all warnings, to be very verbose in that regard. So you type GCC -w all, this stands for warnings all, and then example for .c -o, example for .o. So no warnings whatsoever. So then let's print example 4. Just a remark here, we will be posting this in a GitHub repository, so you can download all these examples without typing them and check out them out later. But I strongly recommend that you follow along and type as I type it. Okay, so as you can see here in my machine, the size of an int is actually 4 bytes, Then we have size of short int, which is 2 bytes. Size of long int and size of long int are both 8 bytes. Okay. Let's test some other variables here, like float e, double f, and let's test for char g, and then I guess that's pretty much it. Okay, so printf size of float e, printf size of double sorry, ld \n size of f, then printf size of char. Okay, so we compile again and run. So as expected, we have size of float is equal to integer, which is 4 bytes. Size of double is the double bytes of a float, so it's 8 bytes. And then the size of a char, a character, is 1 byte, equals to 8 bits as expected. What I wanted to show you here is another variable type in C. Okay, let's in C you can insert comments in your code by typing // like this, so this lines here won't be executed. Okay, also you can insert comments like this /*. This is a comment, so it's usually if you want to remember, if you wrote a complicated function, a piece of code, and you want to remember what exactly is going on, then it's usually a good practice to comment, and then at the beginning of the function, perhaps here we can, let's say, shows different size in bytes of C type variable types. Okay, so we can compile this, and okay, so as I said, with this flag here, the compiler will warn us of unusual variable, since we are no longer printing these variables here. So C compiler alerted us, gives us alert that these variables are actually unused. Okay, but it's a warning, it's not an error, so it doesn't forbids us from executing our code. Okay, so, and we can remove this flag here if we don't want to see that. Okay, but I will retain it for now and then execute our code. And as expected, nothing happens because the lines of code that were actually being run before were commented. Okay, so there are other types of variables that I haven't mentioned in the previously example, like in C. We have unsigned variables, like unsigned int, let's say unsigned, let's call it num1, and we have unsigned long int num2, unsigned short int num3, and unsigned long int num3. Okay, so basically these variables, integers which are equal or greater than 0, so no negative values. So if you try, for example, to assign num1 equals to -1, it should give an error. So let's test it. Printf num1 equals to, as it's an unsigned value, we need to include here u for unsigned, and then only u for unsigned variable. It doesn't actually uses d, but here is percentage sign u. So num1, and write and quit, and let's see what will happen if we run with warnings all. Okay, so unused variable, so I guess no warnings regarding that we assign a negative value to an unsigned variable. So let's run it, and of course we got an error, which is, this is obviously incorrect. So let's fix it. Let's assign it 1, and then print, compile. Okay, so now we got correct results. num1 equals 1. So you have to pay attention to what you're doing here. For in this case, it gives absolutely wrong result when I try to assign a negative value to an unsigned integer. So let's give let's populate the other variables here, like num2 equals 2, and then num3 equals 3, and num4 equals 4. Okay, so here we have a long int percentage lu for long unsigned integer, and then num3 equals percentage sign, it's short, and short in C is hu. Okay, h here is for short int, and then num3 and num4, which is a long unsigned integer, equals to LLU, then num4. Okay, so let's print this. Actually, let's decomment these lines here so it doesn't annoy us with many warnings. Okay, so GCC, and then execute it. Okay, so as expected, we got the values that were assigned. So let's check something here. I'll be using Jedit for doing this, just for the sake of copy and paste code. So what we'll do here, let me increase the font size. Where is it? Reference fonts. Okay, I think we're good. So this is our C program. I will print this one here. So sizeof unsigned int chart unsigned int. Actually here it's long unsigned short and then unsigned long int. So we have here num1, num2 and num3. Okay, sorry about that, I forgot to turn my cell phone off. So we have unsigned int, which is num1, unsigned long int, num2, unsigned short int, and unsigned long int. So let's save this, close, let's clear this, then print. Okay, so as you can see here, the size of unsigned int is actually the same size in bytes as an int. The size of an unsigned long int is the same size as long int. And as well as for short, unsigned short int and unsigned long int. So you'll be asking why use unsigned variables in C. Well, this is gives you an advantage when you're dealing only with positive integer numbers, and in this case natural numbers, and you want to use so you gain more bytes you can use to represent an integer, a natural integer, a positive integer. So you can display larger numbers by using more bytes dedicated to it. When you use int, you sort of use half what you could use to display a large number in C. So let's create. I want to illustrate this. Let me show you how can you display the largest numbers that you can use for both unsigned and signed int. Just a remark here. Int a and signed int, this type qualifier here, is actually the same, so it doesn't matter if you write either int or just signed int, is the same thing. Okay, so don't worry about that. For now we'll create another example. Example 5.c, and now I guess okay, so let's just start coding. So include stdio for using printf, and now we use our library called limits.h. Okay, this library is used to display the largest numbers in that are a certain type of variable can represent. Okay, so it main void curly brackets return 0. So let's start with let's start with shorts, int a, int b, long int c, long int t, and then for the unsigned shorts, actually we don't need that because we will just printing the limits, and limits are defined as constants, so I might have to take a look. So let me see if there's a manual for this. In case you're wondering, in Linux you can check if you're in doubt how to use a certain function. You can use a command type, for example man, which stands for manual, for example printf. Okay, so here is the manual for the printf function. Here you have all the different special characters for formatting. The author, so David Mackenzie was the guy who wrote the printf function. And okay, so let's see if we got the manual for limits.h. Okay, so no manual. So let's check our big old friend Google. Okay, so let's check for limits.h. Okay, so we have some macros on limits.h. For example, we can display the maximum short value, maximum long value. So let's for signed and for unsigned long, signed long. So let's print this value here. Don't be ashamed of using Google. I use Google a lot to googling stuff I don't remember. So let's print max first, max short, minimum value for short, and is it shorts? It's HD, and then we print a macro here. I will test this one over here. So example 5, and voila. Okay, so it's working, and let's see if it's the same. Okay, so it's the same, and then let's see for short max, sorry. So printf shrt max, and then HD as it stands. Remember, this H stands for short, and then shrt max. Again, all these macros here are defined in this library here, limits.h, and then we can print let's see int min, printf int max, and then we have long int here, long, it's long min, long max ld backslash n. Let's see what else we got. Then we have, I believe, the unsigned variables, unsigned short. Remember the minimum value for an unsigned, either it's whether it's a short, it's a int, it's a long, it's 0. So all minimum values for unsigned integers are 0. So let's check variable for u short. Let me check once again. Short max, it's u, it's hu. Okay, u short max, and then u int max, lu, and then long unsigned long int max. Here is just u, and here okay, now let's comment this code here. Prints the maximum values of variable types. Okay, so let's compile and run. No warnings whatsoever, and then example 5. Okay, so these are the minimum and maximum values for short integer. For an integer, for long, minimum for long, max integer. Here you can see how doubling the bytes increase the number you can represent. And for unsigned short integer, as you can see, it's bigger than the signed value for short. The unsigned value for the maximum unsigned value for an integer, it's basically double the size of int max, and the maximum value for unsigned long integers, which is bigger than the signed value for long int. So guys, for this video, this is it for this video. I hope you guys enjoyed. See you next time. Don't forget to like, subscribe, and comments. And on the next video, I believe we will start talking about user inputs and if statements. Okay, see you next time. Bye.